Yeah.
Hello, my name is Muhammad Dini Fakir Yaakob. We are from group M4C. So today we will explain a bit little about the question for Viva. So the first question is explain what do you understand about gigamultitude. So uh, for me what have I understand is gigamultitude is a device used for detect and measure all types of radiation, which are alpha, beta, and gamma radiations. So basically, this tube consists of a pair of electrodes surrounded by gas. Uh, the gas used is usually a helium and argon. So when the radiation enter the tube, it can ionize the gas. So uh, this ion consists an electron are attracted to the electrode and an electric current is produced in which are uh, called pulse. So and then the scalar count will count the total pulse in the time taken. That's all for me. So how about you, Zarif?
Okay. Hello. My name is Amirul Zarif bin Hamizi, and we are from Group M4C. So, we are going to present our lab report that the experiment for radioactivity. So, as you can see, Daniel had already tell about the first question that explain what do you understand about gigamolar tube. So for me, the gigamolar tube, or we call it as GM tube, is the sensing element of the giga counter instrument used for detection of ionizing radiation. The gigamolar tube, it was named after the Hans Giger, who invented the principle in 1908, who invented and Walter Muller collaborated with Giger in developing the technique further in 1928 to produce a practical tube that could detect a number of different radiation types. So, because of these two scientists, therefore the gigamolecule has came to detect the radiation type. So, gigamolecule can detect gases ionize. It is became a gases ionization detector and uses the Townsend avalanche phenomenon to produce an easily detectable electronic pulse from as little as a single ionizing event due to a radiation particle. It is used to detection of gamma radiation, X-rays, and alpha and beta particle. So for our experiment, we use this gigamolecule to detect the beta particle. So, Daniel, you can proceed for the second question.
Okay, for the second question, explain the working principle of gigamultitude. So my answer is wait, a gigamultitude consists of many things. First of all is mica, the thin mica window, which is to allow the alpha, beta, and gamma radiation particle to go into the tubes. So we use this thin mica window because it's allowed the it allowed the particle uh, we cannot use a paper because paper block the alpha particle. So the second principle, the second thing is uh, this gigamolecule consists two electrode. Uh, these two electrode function to block the particle from other side except the front side. After that, we have positive electron in the middle of the tubes. So for positive electrode, it's not connected with other electrode. So when the radioactive go inside the tube, it will ionize gas in there into negative ion and positive ion. So the positive ion will attract into the negative electron, and the negative ion will attract to positive electron. So when negative ion attract into positive electron, it will generate a small current, which we call the pulse. So the pulse will be count by the counter, uh, by the counter. So we will uh, know the total of the count using the counter. Uh, you, Zarif, how about you?
So, for the second question, that we need to explain the working principle of gigamolecule. So, first of all, we need to know the component of gigamolecule. So, if we can see the gigamolecule, it has a mica window. Then it has a anode and cathode. It also has a radioactive source, which the source of radioactive particle that we can put it for the flow to ionization. So it also has a scale meter or rate meter to count the number of particle, ionization particle. So now I will explain the working principle of gigamolecule. So as we know, the gigamolecule is used to detecting the radiation. So the GM tube is a hollow cylinder filled with a gas at a low pressure. The tube has a thin window made of mica at one end. There is a central electrode inside the GM tube. A high voltage supply is connected across the casing of the tube, and the central electrode are in the gigamolecule. So, when the radioactive source such as alpha, beta, or gamma radiation enter the tube, it produces ions in the gas. So, the ions created in the gas enable the tube to conduct. So, a current is produced in the tube for a short time. The current produces a voltage pulse. Each voltage pulse corresponds to one ionizing radiation entering the GM tube. The voltage pulse is amplified and counted. So the greater the level of radiation, the more ionization the tube, so the greater the number of count. So when the level of radiation is increased, more ionization in the tube, so the rate meter or the scale meter will increase the counting, and we can collect the counting for data for our experiment. So the GM tube counting, the number of ionization may not provide a completely accurate reading, as the number of counts will simply keep increasing. So there is mathematical and a formula to use for calculate the error analysis of the radioactivity experiment, because there is not a completely accurate reading when we taking the data. So okay, Daniel, you can proceed for the third question.
Okay, the next question is explain the characteristic of curve of gigamolecule. So the characteristic is, first we have starting voltage. Starting voltage is the lowest voltage applied, which is when we apply the voltage, the count is zero. So these voltage are the starting voltage of all. So, and second, we have threshold voltage. A threshold voltage, we can find when the count, when we increase the voltage, the count the count is repeat. For example, when we increase the voltage, the count is between 50 to 60, 70, and then it's repeat back into 52, 53. So we can find the threshold voltage, which is the first voltage before this repeat happen. So second, we have plateau region. Plateau region is between the repeated count. And then we have the discharge region which happen after the plateau region, which is after the breakdown voltage happen. So the breakdown voltage is when the count suddenly shoot into different amount of the repeat. For example, if we have the the repeated count between 50 to 80. So after the breakdown voltage, the count will shoot into 300 or 3000 count per time we are taken. Uh, uh, that's all. So Zadif, can you explain what you understand about the curve of gauge-molecule?
Okay, so for me, hello, can you hear me?
Uh,
Hello,
yes,
okay,
we can. So, can
okay.
you?
So, for the third question is explain the characteristics curve of gigamolecule. So, as I and Daniel and I do a same experiment. So, we have we can see the same curve of gigamolecule. So, for example, when we start the experiment with voltage, for example, is 500 and the counting is 0. So actually, that is the low applied voltage. At a very low voltage, the current rate is insignificant. Tubes cannot generally be operated usefully in this region. So if we increase the number voltage, for example, 520, if the count is still 0, means that is the low applied voltage too. So as we increase the voltage in at 600 and the count number is increased, so that is the starting voltage. As you can see, characteristic curve of a circuit, that Vs. Vs is the starting voltage. So the starting voltage is defined as the lowest voltage applied to a counter tube which pulse can be detected. So when the pulse is detected, there is a counting, but it is very small and little because it is a starting voltage. So at the curve also we can see the threshold voltage. So above the starting voltage, the count rate increase rapidly. The voltage is further increased to reach the threshold voltage. So the threshold voltage is we can see the significant increase that the number from the starting voltage is very different. For example, if I put the voltage is 600 and the counting is increased rapidly, so that we can call it as threshold voltage at 600 voltage. So then we can see the plateau region. The plateau region is the region that from the threshold voltage until the breakdown voltage. So the plateau region is basically the counting is very similar to each other and not the rapid increase or rapid decrease. So the plateau region, we can see when the threshold voltage also mark the beginning of GMQ plateau for the condition under which the circuit is operating. Past the threshold, further increase in voltage result in negligible increasing of rate. So this is called a plateau. So we can see from the experiment the plateau region is really significant as the number of voltage that used is more. After that, we have discharge region. So discharge region occur after the breakdown voltage. So as we increase the number of voltage, there is a significant rapid increase on the number of counting rate. So it is called the discharge region. For example, when just now I told you that 600 voltage is the threshold voltage, so it will increase along the plateau region. So for example, 900 search region. So the counting rate is very different from the counting on the plateau region. So that's we can see that the rapid increase is the discharge region, and it is not the plateau region anymore. So I think that's all from me about the characteristic curve of bigger molecule. So Daniel, you can proceed.
So the next question is, explain what do you understand about the experiment A and the procedure to taking a data. So for experiment A is to identify the operating voltage, which is we can find using the curve of Giger molecule. Uh, First of all, we fix the value of the time taken during all this experiment. So, for example, for this experiment, we are fixed the time taken is 30 seconds. Uh, After that, we choose one voltage to start the experiment. For example, we choose 600 voltage and count the pulse. If the count is zero, we just proceed with other with for example, if 1600 voltage we got zero counting, so we just proceed into to 700 or 650. But if we got other than zero, we need to reverse the voltage to find the starting voltage, which is when the value of count is zero. After that, after we find the starting voltage, we need to increase the amount of voltage in interval of 20 or uh, in interval of 20. So for example, if we got the starting voltage is 600, so we need to find the counting rate for 620, 640, and after the 640. After that, when if we observe uh, and after that, if we continue increase the value of voltage and we observe that the count is repeat for example repeat 60, it's repeat back to 50, or uh, re- 60 repeat to 80, like that. So we know the threshold voltage. The threshold voltage is we can find is threshold voltage is the value before the starting the before the repeat counting started. After that, if we further the voltage, the count we should just like we thought about the graph at the curve, so we can find the breakdown voltage. So after we find the breakdown voltage and the threshold voltage, we can find the operating rate voltage. The operating voltage is between the threshold and breakdown voltage. After we find all these value, we can plot the graph count counting rate versus voltage. In the graph, we also need to conclude we need also count error for y axis. So the error is actual value plus standard deviation, or actual value minus standard deviation. So that's all for me. How about you, Zali?
Okay, so for the first question is explain what do you understand about experiment A and procedure of taking a data. So actually for the experiment A, it is uh, it is to study the characteristic curve and determine the operating voltage for a gigamolecule. So for this experiment, you need to fix the time as Daniel said, and the counting reading we can do it 3 times. So for example, for the 1 voltage, we can do the counting of the ionization 3 readings, and we can take the average for our counting. So for example, the starting voltage is 600. So as the counting is 0 for the three counting, so the average is 0 and the counting rate is 0. So as we increase the voltage, the 620, the counting is start to increase. That is 1 for 3 readings, and the average is 1. So we can increase the voltage for us to taking the number of count for 3 times, and we can take the average as the count, and for the count rate we will use the count average divide with the time to get the counting rate. So as the objective of the experiment is to determine the voltage, so we need know uh, the voltage, the threshold voltage, and the breakdown voltage, because between these two voltage, it is the operating voltage. So as we do the experiment and we collect data, we can see at the 700 voltage is the threshold voltage, that the voltage is increased significant, and there is a stable number of increase until a breakdown voltage. The breakdown voltage that we get from this experiment at 900 is at 940 voltage. So we can determine the operating voltage by uh, uh, when we look at the graph of the gigamolecule graph that we have explained before, and we have to do the standard. We have to do the error bar for each point at the graph, because the error bar is represent the counting rate of the what we call the graph, that we need to plus minus with its standard deviation. So for the experiment A, I think that's all for me. So Daniel, you can continue for explain the experiment B.
Okay, for question that explain what do you understand about the experiment B and the procedure of taking. So what I understand is in the experiment B, we just using the operator value uh, from what we got from the experiment A. So for example, the operator value we got is 840 voltage. So so we need to count and counting the rate. So we need to use repeat for 20 reading, and then we need to find the count and the counting rate. Also, we need to uh, find the standard deviation using the formula ZR over T, and we also need to find the error for the standard deviation by using the mathematical formula. After that, we from the bell curve, we can find the mean and the mean. After that, we plus plus minus the error of standard deviation to find the range for standard deviation. After that, we go back into the go back into the counting rate, and we need to identify if the counting rate lies between the range of mean plus minus error. Uh, for example, from 20 reading, we got like 10% 10 reading lies between the range of standard deviation. So from if we got 10 reading, it means that 50% of the counting rates lies between the regions. So but in our experiment, we need to make sure if it's more than 68%. Uh, that's all for me. How about you, Zalif?
Okay, so I will explain for the fifth question that about experiment B. So what I understand about experiment B is to show the standard deviation for a single measurement R can be estimated as surd R of T with 68% confidence for a high value of clear radiation counting rate. So so for the experiment B, we have to fix the operating voltage that is 840 for my experiment. So the count times taken is still the same, 30 second, and we need to take 20 readings of the count. So as we take the 20 readings of the counts, we can calculate the counting rate, and for that we need to do the standard deviation for the counting rate. There is two standard deviation that we need to do in this experiment. That is first the standard deviation that is we can use the formula, and second is the mathematical standard deviation. So actually the mathematical standard deviation is used to calculate the plus minus of the standard deviation that we use by the formula. So we can do the experiment B uh, with uh, with taking the data and calculating the standard deviation for the formula and for the mathematical standard deviation. So we can see that the the we can see that there is a probability distribution curve. So we need to count how many standard deviation that satisfy in the 68% of 68% region that you can see from the probability distribution curve. The standard deviation also need to, plus and minus uh, uh, by the mathematical standard deviation get the to get the middle part of the curve. So I think that's all for experiment B, and then we proceed for experiment C.
So the final question is what we understand about the uh, experiment C. So the objective of experiment C is to find the minimum thickness of the medium are required to stop the radiation. So the procedure is adding absorber between radiation source and detector. So from the experiment, uh, we need from the experiment we change the thickness of absorber and find the value. So we have done we have done 10 times reading. So after that, we plot the graph with the graph R versus thickness of absorber. So from the graph, we can find the range of beta radiation, which is the intersection between the background radiation dengan with the rate of R, rate of counting values. And that's all for me. How about you, Zadif?
So for the last experiment, experiment C, it is conduct to determine the range of beta radiation. As you can see, there is the thickness of the absorber, because it is used to determine the range of beta. So for the background reading, we need to do the background reading. So the background reading, we will take 10 reading of the operating voltage. So we can counting rate the reading, and we can do the standard deviation for the reading. So the background reading is the count without the radioactive material. So for that, we will the absorber is between the radioactive source and GM tube detector. So we can take the count reading 3 times again, and we take the average. So we will counting the rate like we do the experiment A and so after that, we can determine the range of the beta by uh, by by we can see the different absorber thickness that contribute the different beta range that penetrate the the experiment C is very simple and very little. So I think that's all for me. So Daniel, what do you want to include?
Before we end our meeting, I want to share my calculation using Excel. So wait a minute, let me share the slide first. So, Zarif, you can see that.
Yes, yes.
Yes. So for experiment A, for experiment A, we had find the counting rate and standard deviation. So these are the value. These are the data from the lecturer. So these are for experiment B. We had find the counting rate and standard deviations. Also for experiment C, we have find the counting rate, standard deviation and the counting rate count uh, and for the all the data here. So Zarif, do you have any any other thing to say? So I
I
will
think
stop.
for us we use Excel for our calculating. So I think that's all from us for this experiment. So I don't have any word to say, and I will say thank you.
Thank you.
Okay, thank you.